1. So ready? So the path of a baseball that has been hit can be modeled, right? You're modeling, right, by the following equation, where h is the height in feet and t is the time in seconds. Okay. So before we start, what you were actually given a very important piece of information. You know that this is y, right? And this is your x here. X is on the right side. So you were told that the x values right now represent time, and the y value, which is h of t, represents your height. Okay. Every single point on this parabola, yes, you will be given x and y because the calculator doesn't know any better, but we will know that it will give you the time and the height at any given moment, right? That's what the coordinates will represent for us. Okay, so A is asked, look at all these questions. Isn't that crazy? Anyways, what is the initial height? What's the initial height of the trajectory of the ball? Right? In other words, at what height was the ball hit? Okay. So for A, initial height is given by what? We know this as the y-intercept. Okay. This is in general form. So y-intercept is 0, 4, right? We know that it's at 4 here. Okay. Therefore, initial height is, and it's a word problem, right? Don't just say 4. 4 what? What is it measured? What's height measured in? Feet in this case, right? That's it. Nice and easy. Determine the maximum height of the ball. Max height is achieved at the vertex. So notice how I'm using the terms that we've been associating or using to just look at the parabola and analyze it. Now, oh, okay, max height is at the vertex. So the max height is at the vertex. So let's enter this into our calculator and find the vertex, because we're going to need to do that, right? Your best bet is if you have an equation, type it in. Most likely you will need it. Just a reminder, make sure plot 1, 2, and 3 is not highlighted. We do not need it yet. You will need it down the road. So we go negative 4.9. What happened there? Negative 4.9 x squared plus 35x. We don't have t, right? Plus 4. Let's graph this. My window is terrible. So I'm just going to go zoom 6 for now. You remember zoom 6? What is zoom 6 again? It's zoom standard, right? That's better. We expected it to be pointing down because it's negative, right? So I'm just going to increase my y max a little bit. I'm going to go 50 for now. Let's see if that does the trick. Not yet. Go back to your window. There you go. Do you need the negative 10 on the x-min? You don't need it. So if that bothers you, I'm going to reduce that to like negative 2 for my x-min. I like to see a little bit into the negatives, okay, but not a whole lot. So that is good. That's a good window right there. You can see it all the intercepts, vertex, you're good to go. So let's go ahead and find the vertex. Second trace, maximum. Go to the left of it, go to the right of it. And I get 3.57 and 66.5. So you tell me, you're using your calculator, right? So all you have to do is second trace max in this case. And that would be 3.57, 66.5. So write down the coordinate, right? And then you will say that the max height, some students just leave it at that. It's like, hey, there, Mr. Dirksen, you like that? I'm like, you're close, but you're not telling me what the maximum height is, right? It's like the Easter egg hunt. You're warm, it's getting warmer, but you're not quite there. So this is what we want. Maximum height is 66.5 feet, right? So this is part of your work to go get that coordinate, and then you make a short little sentence. I'm not too picky with how long your sentence is, right? Just make sure you give me the bare minimum, but include units. Okay, so you have that. C, how long does it take for the ball to hit the ground? In other words, how long will the ball remain airborne? Ball hits the ground. At the x-intercept. I think we can all wrap our heads around that, right? Ball hits the ground at the x-intercept. So we're going to go ahead and do that. y2 is equal to 0. Second, trace, intersect. But hold it. Yeah, let's do it. Let's go ahead and look at our screen. Make y2 equal to 0. Do we care about the negative, the x-intercept that is possibly on the negative here? Do we care about that one? The answer is no. The story starts at time is equal to 0. So don't take the negative x-intercept. All we care about is the one over here where the ball will land. Okay? So second trace 5. You go close to it, enter, enter, enter. And that's 7.260. Okay? So you write that down. 7.260. I want you to find the negative though, because I want to make a point when you review for the exam or whatever. Second trace 5 again. I'm going to jump to the red line. So I'm going to use up or down arrows. And I'm going to go all the way to the negative. Closer to it at least. That's good enough. Enter, enter, enter. That's negative 0.11. Okay? Negative 0.11. And that's also 0, right? We will say this, right? Omit. Okay? Time can't be negative, right? So we don't care about that negative x-intercept. Okay. So we know that from 0 times 0 till 7.26, right? It tells us that 7.26 seconds went by, right? A ball remains in the air for 7.26 seconds. You're done there. I will just say here, a note here, starts at 0, starts at, make sure you understand this, at 0 seconds, right? Ends at time is 7.2 seconds. So we would not include the negatives, the negative 0.11, right? D, calculate the height of the ball. 1.5 seconds after being hit. This is what I want you to see here. When x is equal to 1.5, what is y equal to? That's what this question is asking, right? They're giving you the time, they're not giving you the height. So basically, you know that the point you're after, you know the x coordinate is 1.5, but you do not know the y coordinate. You don't know that. What function would you use on your calculator to figure this out? Which one allowed us to enter an x value and it would give us back a y value? Moses? What's that? Value. Second trace 1, right? Second trace value? Yes. Second trace. I told you second trace is going to be your go-to, right? You're going to use it a lot. Value, x is equal to 1.5. Soon I'm going to replace these words here with a number. I'm just going to go second trace 1. That's value, right? You're going to know that, right? X is equal to 1.5. So let's do that. Second trace value, so I hit enter. That's 1.5. And watch, it stops right there. When x is equal to 1.5, y is equal to 45, 48. Okay, that's rounded. So we just go comma, 45, 48. And you know the beauty of this? If you just add a unit here, I will give you full marks. You're saying this is the answer. The ball is at 45.48 feet after 1.5 seconds. All right, let's keep going. Okay, E. This is interesting. Okay, so here you're gonna have to use your brains a bit more. Okay, E. Determine. I'm just gonna go up here. Determine the time the ball remains at or above 49 feet. Okay, what's up with that, right? So I'm going to give you a diagram, a little sketch to help you visualize this. So this is not drawn to scale, this is not a graph, so it's okay to just eyeball it, right? This ball is not hit it like you don't hit it right on the ground, it's a little off the ground. We're at 4 feet, so it's somewhere in here, then it goes up, and then it will hit the ground. Unless somebody catches it, of course, right? So I can put a twist to it later. We know that 49 feet is somewhere up here, right? This was 4 feet, so 49 would be somewhere here. This is going to be our 49-foot mark. There's going to be a time where the ball reaches that height for the first time, make a dashed line going down. I'm going to call this time 1. And there's going to be a time where the ball comes back to 49. That's going to be time 2. Okay. So let's go ahead and find those 2 instances. All right. So what we will do here is, let me just make some camera adjustments here. We will make y2 equal to 49. And then we're going to go second trace intersect. That's what we're going to do. You ready for this? But Mr. Dirksen, we used to do this for the x-intercept, right? Yep. We're just putting a little twist to it. It's now 49 is the line we're interested in. So grab your calculator. So if it happened 60 feet, if it happened 250 feet, it doesn't matter. You put that into Y2, then hit graph, and there it is. Okay. So let's find the 2 times we reach that 49 mark. Okay, we're going to do something with that, and some of you can probably imagine what we're going to do with those 2 numbers. You grab the first one, enter, enter, enter. But watch what I'm going to do. This is crucial for getting full marks here. You're going to write down 4 decimals. 1.68. This rounds 6816 if you round to 4 decimals. Right, so that's the first time. And then get the second time. Second trace 5. I'm taking the long route, the scenic route. Enter, enter, enter. And that's 5.4613 rounded to 4 decimals. Okay. Why 4 decimals? Because we don't want to round too soon. We're not done yet. Okay, we're still working. Let's use, where I will put this, use 4 decimals. Okay, very important. Use 4 decimals. Exclamation mark. That's the time Mr. Dirksen yelled at us. So now we have, what we're going to do is this. I don't know if you've been in physics, I'm sure you've seen delta before. Delta T, it's basically the time that elapsed, is time 2 minus time 1. Okay, the time that went by, the difference between the times is going to tell us how long you were above it. Right? So we're going to go delta T is 5.4613 minus 1.6816. You know what's better than 4 decimals? All decimals. But I know that's a little tedious, so it's okay to not have the whole thing. So you either use mental math or you just go to your home screen, second quit, right? Second mode, I guess, quits the screen. And that's 3.78. So at this point, you can round to 2 decimals. Oops, that's my phone. This is spent, right? Spent at or above 49 feet. If you have a highlighter, I want to right away use this for something else as well. So you highlight this, this yellow highlighted stretch. That's the time you just found. Okay, you found the time that the ball spent at or above. But what if the question asked you for below 49 feet? How long was the ball below 49 feet? Time below, okay, sorry, below 49 feet. Anybody willing to chip in how you would find that? You have everything you need, you just need to pick the right numbers. How long was the ball in the air in total? 7.26 seconds, right? Let's subtract time at or above, right? This is another way of looking at it. And that's actually 3.48 seconds. And I'm going to highlight that in orange so you can see. And I'm going to write under this, if you don't mind, right? You go total minus time above to above. Yeah, it works. You know what I mean. This is rare, but it comes back to grade 12 applied. It happens sometimes where they ask you for time below. And it's actually fairly easy. Just find the time above, subtract that from your total time spent in the air, and voila, you've got it. This is much quicker than finding time from here to here and then time from here to here and then adding those times together. It's more time consuming. Okay? So this is a bit of an aside. You won't use it a whole lot, but it does come up from time to time. And now that I showed it to you, I might actually ask you for it. Okay, we're not done yet. Where are we at? F. Graph this scenario. So I provided a nice grid on the back side. You're welcome. I will give you grids quite often because I like nice graphs, and I know that with technology you could do it just like that, right? So I don't always expect you to do it from scratch, right? But here we go. Let's do the basics, and I remind you: scale, intercepts, vertex, and label, right? So let's do that first, so we don't lose any marks. So this would be time in the seconds, and therefore use most of the graph. Okay, don't have scales that are so small that you just have like a little tiny curve on the corner here. It's not wrong if you're consistent, but right, height would be in feet. So make sure you have the label and the unit. Okay. Let's say I didn't ask you for everything I just have. You would on the side here do a little inventory. X-intercept, you would say 7.26, 0. Y-intercept, I know that that's 0.4. Vertex, I know that that is, I'm peeking here, 3.57, 66.5. And again, it's a word problem, so do not be adding the negative x-intercept here. Don't do that, right? Like it's a word problem now. We're sticking to the quadrant 1. So this is your little inventory, right? Intercepts, vertex, right? Let's start plotting. If I go up to 10 on my x-axis, that's as far as this thing should go for sure. So let's see here. Make sure the markings are clear. 2, 4, 6, 8. That's what I'm going to use, right? You could go one further. It's up to you, but this tells me that you're consistent. I don't want to see, right, 1, 4, 6, right? Like if I see inconsistency, you lose a full mark. So go up by the same amount, same gap. Okay. For my y values, I need to make sure the vertex fits in. That's 66.5, right? So I'm going to go to 70 or 80, something like that. So I'm going to test it first. 20, 40, 60, 80, that would work. 10, 20, 30, 40, 50, 60, that's cutting it a bit short. You don't have enough room, so I have to go up by 20s. You can go up by 15 if you want. I just want you to be consistent, right? So the scales are different, but they're consistent. Every axis can have its own scale. And you will see that soon we're going to have thousands, right? Hundreds of thousands, right? So you need to be able to adjust your window, of course, to make it fit. So let's put the points down. 0, 4. this would be 10 for me, right? This is 10 right here. So this is 5, 4 is right there. Just make sure it doesn't touch the origin. Right? That's my y-intercept. My x-intercept is 7.26. So 7 is right here. This would be 7.5. So 7.26 is somewhere there. And the vertex is 3.57. So this is 3 here, between 2 and 4. 3.5 is right about there. So I'm going to go all the way up to, this is 60. That would be 70. So I'm just going a little bit down there. That's it. So that's all you need to sketch it. So I'm going to start with the vertex, go out a little bit, and then down, curving down. Same with the other side, out, then down. I'm going to include my equation. So that is a full mark graph right there. Can I just add to the label up here? Label says name and units plus equation, right? Plus equation. State the domain and range. That's G. G. Let me do the domain and range right here. I quite often ask for the domain and range after the graph. I find it's a little bit easier to come up with it. But if I don't, you just need to find the points, right? You need to find your intercepts, your vertex. My domain would be, sorry, was that G? I'm just gonna check because I feel like I make changes. Yeah, so we did F here. That's F, and then G is here. My domain here is not too bad. It would be 0 along the x-axis, right? From 0 to 7.26. I like interval notation, I'm not gonna lie to you. But you need to be able to read them both. My range, what's the lowest, smallest y value? It hits the ground, right? So it's 0. We're assuming that it's not going to go underground, right? The question would have to, obviously it's a baseball, right? But if it does go underground, we would tell you that, right? 0 all the way to the highest point you ever reach is the vertex in this case. So that'd be 66.5 feet. So there you have your domain and range. And now you got to be ready for this one. Just write this all down. Make sure you have this down. And then let's go back and read H. H is because I'm lazy. I don't want to do a whole other question to do this. But read H with me here. State the domain and range of this scenario, assuming, what does it say there? Let's assume that the ball was caught 6 feet above ground. So somebody actually caught it, right? So this scenario is when it just gets hit, nobody catches it, hits the ground. But what if somebody came, this is 4 feet, 6 feet would be right about here, catches it right there. What happens then? How's my domain and range going to change? So That's why I put this one here. So let's do H here. And if I don't ask you to graph it, make a sketch, please. You hit it at 4 feet. You reach the same vertex. Let's make it very obvious that it gets caught at 6 feet here. 0, 4, 3.57, 66.5. What do we know about this point? Do we know what time it happened at? We don't. But we know that it was caught at 6 feet. Okay. Do we need this point for something? For a domain, right? Starts here, ends here, according to the graph, but we don't know exactly what x value that is. How could we make this happen? Okay, so from 0 till here, this is a question mark right now. We need this for our domain, right? So we will do this. Y2 is equal to 6, because we know that one, right? Y2 is equal to 6. Second, trace, intersect. And let's find the x value. Use your calculator. You're going to use it a lot. It's going to be your best friend. No, not your best friend. It's going to be a tool, right? Very helpful one. So there's my y equals to 6 line. So I'm going to go second trace 5. I don't care about the first instance, right? I care about the second one here. Unless the question asks how long did it stay at or above 6 feet, right? Could have asked that, but it didn't. So there it is, close enough to that one. Enter, enter, enter. We expect it to be less than 7.26, right? So this is actually 7.09. Usually a domain and range question is just 1 mark for domain, 1 mark for range. If it's 3 marks for domain and range, you're probably going to need to do some extra work. Okay, extra work required. Worth a mark. So now that we have this, I'm going to make an arrow go to that one there. And the same thing as this one here. So it's 7.09. Okay. And now we can state our new domain and range. My new domain is 0 to 7.09. Does it really matter, Mr. Dirksen? We're talking about like 0.19 or something of a second, right? But it's still, the point is you need to account for that, right? That it's caught. It's going to end sooner. And therefore my range, what would my range be? Try to figure that out. I'll give you a minute to come up with the new range. Fun with it, right? So let's go with range. The lowest is 4. The highest is your vertex, the y value of the vertex. Okay. Just got to make sure lowest then highest, right? So, Mr. Erickson, why wasn't it earlier? Why wasn't 4 in here? Because the lowest value there was 0, right? For the y that hits the ground. So look at the whole curve before making your decision. Okay. This is H, right? One more, I. And then we're done. That's it for today. I'll just give you a few to try, right? Write another equation that would model the path of a ball with a lower maximum height. You got to be kidding me, right? I don't know how to do this. Yes, you do. The value of C, what does C do? It actually raises your curve up or down. Shifts the curve up or down. My iPad here. I'm gonna block it for a bit just so you see. Just so you see, right? That wasn't planned, but the value of C shifts everything up or down. Right? See that? So if you want a lower, so this is, let's say before we had a 60, right, as our max. If you want another modeling, another one with a lower maximum height, you just have to reduce the value of C. Right? If you want a higher maximum value, you would increase it. So here it's really up to you, as long as you make it known to me that you're decreasing it, right? So let's decrease C, right, to reduce maximum height. So this is an example, right? You could have height in terms of time. I'm going to leave everything else untouched, exactly the way it was. But I'm going to use a red pen or something like maybe a blue pen. I don't have a red one here. Oh yeah, I do. I'm just going to, did it say lower maximum height? Yeah, lower. So I'm going to go plus 3. Okay. And I will make a little note here. Anything less than 4, right? Anything less than 4 will do that one, will do the trick. Because if you had put down plus 3.9999, the maximum height will be lower, right? And let's say you're really stuck. I have no idea how to do this. You could go to your y equals and make another one plus 3. Okay, I'm going to graph the one I just came up with and check. It looks very close, but it is actually lower. Let's make it more obvious here. I'm going to go plus 1. Plus 1. You could do 0. You could do even minus 1 technically. But see, it's you can tell that the red curve is lower, right? So there you go. So this is your homework. Go to the next page there. So 38 to 41. And it's literally 3 questions. You know how in IPR, other courses, it would have been like page 355, do questions 1 to 12, right? You were assigned like 12 questions with like A, B, C, D for each one of them. This is just 3 questions. They walk you through, right? So I would say if you can't do them all, at least do 2. Do the first one and the last one. But I will post the key, all right? Completely filled in detail, okay? Thank you, guys.